Given that g of x and y, a function g, all right, is equal to ln x squared y minus 3y, find a delta g by delta x, that means the partial derivative of g with respect to x. Find b, the partial derivative of g with respect to y. And also find c, the partial derivative of g, the square, delta square g by partial x partial y. Alright? So let's look at part A first. The partial of g with respect to x equals. Now, here, alright, let's take off the equal for now. Here, you have ln of x squared y minus 3y. Now, the thing is, what you have here is a function of a function. So you can use, well, you would have to use a chain rule. Now, if you have been practicing the chain rule a lot, you would be able to use it and do this thing mentally. But let me assume that you haven't been practicing it a lot. Let's do it step by step. Let's write it as g is equal to ln x squared y minus 3y. Alright? Now, let x squared y minus 3y be equal to another function u. So, g is equal to ln u. See that? Now, here, we can find, before I write that, g is equal to ln u. Let's put the u on the left here. Alright? So let me move the let over here. U is equal to, as we're more accustomed to working from left to right, u is equal to that. Now, delta g by delta x is equal to the chain rule, delta g by delta u times delta u by delta x. Alright? Now, what is delta g by delta u? Delta g by delta u is equal to 1 over u. You remember that when we have y equal ln x, then dy by dx is equal to 1 over x, right? And that is in your table of derivatives. Differentiate ln x, you get 1 over x. Alright. Now what is delta u by delta x? So we're looking at this now to differentiate. You'll treat y as if it's just a constant. That means 3y is also a constant. When you differentiate the constant, you get 0. So in this case, you get 2xy. So therefore, delta g by delta x is equal to delta g by delta u, which is 1, which is 1 over u, times delta u by delta x, which is 2xy. Now, when you rewrite u as to what it was in the originally, times 2xy, you're going to get 2xy over, and then this is going to be u, which is x squared y minus 3y. Alright? So, in this case, you get 2xy over x squared y minus 3y. 2xy over what again? X squared y minus 3y. X squared y minus 3y. You see that? Make a note of that. I'm going to erase some part of the working now to make space. Let's get rid of this. Yeah. Now, we want to look at part B. Part B, we want delta G by delta Y. Now, I again will assume that you haven't been practicing a lot of chain rule recently. But if you have been, you would be able to do it mentally. Alright? You would see that when you differentiate with respect to x, is ln something here, which is 1 over this times the derivative of the inside function. So ln of something is the outside function, derivative of that times the x squared y minus 3y is the inside function, so it's the derivative of the inside function. But anyway, suppose we have g, again, g equal ln x squared y minus 3y. Let u be equal to x squared y minus 3y. So we would have g equal ln u. Now delta g by delta y would be equal to delta g by delta u times delta u by delta y. So we're going to differentiate with respect to u. When you say we differentiate that with respect to u, you get 1 over u times, then you differentiate with respect to y. So this part, what do we get when you differentiate with respect to y? We're going to get, hold on, where did I get that? Yeah. So we have 1 over u times the u by dy would be x squared minus 3. Now when we write back everything in terms of x and y instead of u, you're going to have x squared minus 3 over u, which is x squared y minus 3y. So this is x squared minus 3 over x squared y minus 3y. Okay? Now delta squared g by delta squared x delta squared y. Delta x delta y, I mean. Delta squared g by delta x delta y. What would that give us? Remember, we're going to differentiate one of them again, but we will differentiate delta g by delta x with respect to y. Alright? Now, when we look at this, we see that we are going to use the quotient rule. So this is going to be equal to, you hold the bottom first, x squared y minus 3y, hold it as it is, don't make any changes, multiplied by, let me just get some space here, multiplied by the partial derivative with respect to y of the top x squared minus 3 minus, then we hold it up as it is, x squared minus 3 times the partial with respect to y of x squared y minus 3y. So you have that. Let's get rid of this part. So that is equal to x squared y minus 3y multiplied by, when you differentiate this with respect to y, what do you get? 0. Alright? Remember, if you imagine a y is here, it will be y to the 0. And when you use the power rule and bring the 0 down, you're going to be 0 times whatever you get there, which will be 0. Alright? Minus x squared minus 3 times, when you differentiate this with respect to y, what do you get? Well, it's going to be x squared minus 3. Okay? So, what you have is negative x squared minus 3 squared. If you want to multiply it out, you could say is x squared by x squared is x to the 4th minus 3x squared minus 3x squared, which is minus 6x squared, negative 3 by negative 3 plus 3 is 9. Alright? So it would be that. Negative all of that, which you could also write as negative x to the 4th minus, no, plus 6x squared minus 9. Okay, so that's what we have there.